This video is about understanding p-values. Now, I'm not talking about the cost of small green vegetables, but what the p actually stands for is probability. Now, probability is all around us, from simple things such as what is the probability of you catching your bus, to what is the chance of you passing your stats test without any revision. Let's take the simple example of rolling a die. What is the probability of you rolling a 6? Pause for a moment if you want time to think. Now, probability can be written as a fraction, as a decimal, and as a percentage. As a fraction, because there are 6 numbers in total, the probability of you rolling a 6 is 1 out of 6. To work that out as a decimal, if you take a calculator and you do 1 divided by 6 equals, rounding that value off to 2 decimal places, that gives you an answer of 0.17. And to work that out as a percentage, if you multiply that value by 100, that gives you 17%. Now that we've explored probability, let's go back to p-values. When you carry out a statistical test, the program or software that you use, such as SPSS, will typically in your output give you a p-value. In simple terms, the p-value represents the probability that your findings were due to chance. So for example, if your output said that your p-value was 0.05, what this means is that there is a 5% probability that your findings were actually due to chance. Let's have a look at an example to explain this further. Imagine that you came across the following 3 options for medication. The first is effective at a probability value of 0.07, the second is effective at a probability value of 0.003, and the third is effective at a probability value of 0.6. Now the question is, out of these 3 options, which is the medication that you'd be more likely to recommend? Pause for a moment if you want time to think. So the answer to this question would be option 2. This is because it has the smallest p-value compared to the other options, which illustrates that it has the smallest probability that the findings of it being effective were due to chance. We can illustrate this further by converting the decimal values into percentages by multiplying them by 100. Pause for a moment if you want time to think. As you can see here, option 3 is the worst out of the other options because it has a 60% probability that its effectiveness was actually due to chance. Now we're nearing the end of understanding p-values. One last note to make is that this video has been a simplified version of what the p-value actually stands for. There are other concepts as well that need to be discussed, which include significance values, hypothesis testing, but these are issues we'll cover in the next video. We hope you found this video useful, and for now all that's left for you to do is enjoy!